going to begin talking about vectors, doing practice problems with vectors. Before I want to dive deep into vectors, I first want to talk about and quickly review some ideas from trigonometry. So let's say we have a right triangle. I am going to intentionally draw my triangle like this. So clearly here is the right angle. I am going to label the sides of the triangle A, B, and I'll call the hypotenuse C. And I am going to label the two angles of this right triangle. The angle that is opposite A, I will call alpha, which is like a lowercase Greek letter A. The side that is B, I will call the angle opposite B beta, which is like lowercase Greek letter b. So alpha is opposite A, beta is opposite B, and C is the hypotenuse opposite the 90-degree angle. Now, I claim that there are 5 pieces of information in this triangle. There's the lengths A, B, and C, and there are the angles alpha and beta. I also will claim that if I give you 2 of these pieces of information, if I give you a numerical value for 2 of these, you could find anything else of these 5 pieces of information. And the way you do that is you use trigonometry. So what is important in trigonometry? Well, you have the Pythagorean theorem, a squared plus b squared equals c squared. You have your SOHCAHTOA and your sine, cosine, tangent, all those relationships. So you have SOHCAHTOA. So you have sine of an angle, I'll say sine theta is opposite over hypotenuse. Cosine of an angle is adjacent, which means next to or hypotenuse. And tangent of an angle is opposite over adjacent. You also are dealing with a triangle, and the angles of a triangle should add up to 180 degrees. So specifically, the way I drew this picture, my angles are alpha, beta, and a right angle, 90 degrees. So I could say alpha plus beta plus 90 equals 180. Okay. There are some other relationships that will be important in this course, but I'm going to discuss them shortly. So, for example, if I give you the lengths of side A and side C, you could use the Pythagorean theorem. You plug in the number I give you for A and C, you solve for side B. When you are working with these trig functions, the angle here I wrote as angle theta. What is opposite, what adjacent, what do those really mean? Well, opposite and adjacent, opposite and adjacent are in reference to the angle that you are considering, are in reference to the angle you are considering. What do I mean by that? If I look at this triangle, and I'll just redraw it here so I could label it right on the board. So here's A, B, C, here is beta, here is alpha. From the point of view of angle alpha, this is the opposite side. So this side is opposite alpha, but this side here is opposite beta. So opposite is in reference to, are you talking about angle alpha or talking about angle beta? I want it to be general when I wrote SOHCAHTOA, so I just wrote some other angle, which I just happen to call theta. Opposite, that means opposite the angle you're talking about. Adjacent means next to. So what is the side next to the angle you're talking about? The side that is not the hypotenuse here. So this side here would also be the adjacent side of alpha. This top side here would be the side adjacent to angle beta. So for example, I could say sine of alpha is equal to opposite over hypotenuse, A over C. But I could also say cosine of beta. Well, cosine of beta is adjacent over hypotenuse. So adjacent to beta is right up here. That is also going to be A, and hypotenuse is still the hypotenuse, that's C. But the sine of beta, well, sine of beta, opposite beta here is B. And hypotenuse is still hypotenuse, that is C. So opposite or adjacent are in reference to the angle you're talking about. Are you talking about angle alpha or are you talking about angle beta? And that will be an important piece of information. One common thing that I see that I would like to point out now when we're beginning to work with this to hopefully avoid some confusion down the road, it is often going to be the case that the x component of a vector will be associated with cosine and the y component of vector will be associated with sine, but that is not 100% of the time going to be the case. So don't assume x component is cosine, y component is sine. What you should be doing is you should be saying cosine is adjacent, sine is opposite, and then you look at a picture that you drew, and if the horizontal component is the adjacent, then sure, then the x component will be cosine. But that's not going to be guaranteed to be 100% of the time. Begin with these definitions and then assign opposite adjacent, sine cosine, and relate them to the x and the y components. I will have example problems following what I do here, where I show you commonly what happens, and then I'll show you what a scenario that is not so common looks like. One thing I also want to mention about this piece of information, I told you that if I give you two pieces of information, either the lengths of the sides of this triangle or the angles, you could find any of the other three pieces of information using trig relations. It doesn't quite hold true if the two pieces of information I give you are the angles. And you could demonstrate that by showing, if I give you the angles of this triangle and this triangle, you look at them and you say, well, the two triangles are identical. The angles of these two triangles are going to be the same, but the lengths are clearly different. So if I give you the two angles, that is not enough information to find the lengths of the sides, although you can know the ratio of the lengths of the sides. That won't really come up very often though, I just want to point it out. So, two other things I want to say. There are three other trig functions as well. There is secant, cosecant, and cotangent. They do not come up nearly as often as these three, so I'm just going to officially mention them now, and if we ever see them, then I could say I've mentioned them. So secant of theta is equal to 1 over cosine of theta, which is equal to hypotenuse over adjacent. Cosecant of theta is equal to 1 over sine of theta, which is hypotenuse over opposite. And cotangent of theta is the 1 over tangent of theta, which is adjacent over opposite. So really, secant and cosine are related. They're just inverted of each other. Cosecant and sine are related. They're just the inversion of each other. The very last thing I want to say, the idea of inverse functions. We will work with this. Now, What if I give you the lengths of two sides of a triangle and I ask you to find an angle? So what if I give you say A and C, and I ask you to find B. Sorry, I mean beta. I ask you to find beta. In order to do this, we will use inverse functions. So what I would do is I would first write out, okay, we are given A and C, and we are asked to find beta. So I could write, let's see, beta, A is the adjacent because it's next to, so C is the hypotenuse, so adjacent and hypotenuse, that's cosine. So I could write cosine of beta is equal to, I'm going to leave some space here intentionally, A over C. Now, this is a true statement. I gave you A and C, you would have numbers to plug in, I don't know, 3 and 5, you plug in a calculator, you get some number out, 0.6. What I am going to do is I want to get beta outside by itself. So how do I get this term beta outside by itself? The way I do that is I take an inverse function. So the rule, if we do something to one side, we got to do it to the other side. So if I take cosine inverse of cosine beta, I took the inverse cosine of the left-hand side, I have to take the inverse cosine of the right-hand side. So this would be cosine inverse of A over C. I did something to the left side, I have to do the same thing to the right side. The equal sign will still remain true. Now, the magic of taking an inverse function is this cos inverse will get rid of this cosine. And all that I'm going to be left with on the left-hand side is beta. On the right-hand side, cos inverse A over C, that's just something I will plug into my calculator and my calculator will spit out a number. So I could say beta is equal to cosine inverse of A over C. And then I would just go to my calculator, I would find cosine inverse somewhere on my calculator, parentheses, whatever number A is, whatever number C is, close parentheses, hit enter, and you get your calculator will spit something out. When you do calculations with trig functions, make sure whether you're working in radians or degrees, make sure you're in the correct mode for your calculator. If you are getting a nonsensical answer or an answer that doesn't make sense, maybe that would be the first thing to check. That is very easy to fix. For the most part in this course, until chapter 8, I think we will almost always be working in degrees. I'm not 100% sure, but I'm pretty sure we won't really use radians until then. Also, sometimes instead of cosine inverse, this is written as arc cos. Arc cos and cos inverse mean the same thing. So I could just as well say beta is equal to arc cosine of A over C. These two terms mean the same thing. Sometimes, I think more often calculators use cos inverse, but sometimes they use arc cosine. I just want to point that out. Now this thing that I'm talking about with inverse functions applies to also sine inverse, tan inverse, cosecant inverse. All of those functions exist in your calculator. So as another example, let me give you some numbers. So let's pretend that I were to make a right triangle. So I will say this is a length of 10 and this is a length of 4, and I am asking you, what is this angle beta again equal to? So I could look at this. I notice this side length of 4 is opposite beta. 10 is the hypotenuse. So because I have opposite and hypotenuse, I could say sine of beta is equal to 4 over 10. Now 4 over 10, that's 0.4. I could do that quickly. But if you get weird numbers like 37 and 54, just plug in a calculator, you'll get some decimal out. So I could write sine of beta is equal to 0.4. Now I want to get beta outside by itself, so I could write sine inverse of sine beta, sine inverse of sine beta is equal to sine inverse of 0.4. Sine of beta is equal to 0.4, so whatever the sine inverse of beta is, that will also be the sine inverse of 0.4. I did sine inverse to the left side, I have to do sine inverse to the right side. Now, sine inverse will cancel with regular sine, and all that's left on the left-hand side is beta. Sine inverse on the right-hand side, I plug it in a calculator, I hit enter, and I will get some number. Off the top of my head, I don't know what that is going to be, so I don't know. We'll say it's going to be something like 35 or whatever. I get some number. So, the last thing I am going to say is, it is also true that I could switch okay, I'll put it this way. If you see something like sine inverse of, I don't know, x, I could, if I want to get x out, it would also work to say sine of sine inverse of x. This is also equal to x. Usually in this course, we will have sine or cosine or tangent, and then we take the inverse function on the outside. But mathematically speaking, it doesn't matter if I have sine inverse inside and sine outside, or if I have sine inside and sine inverse outside, these still will cancel all the same. So in the next video, I'm going to explicitly show some examples of applying trigonometry, finding right triangles in vectors, and then we will analyze breaking vectors into their components and finding all the pieces of information about those vectors.